Holy systems, Batman. Today we're going to solve systems algebraically. You've done this before, but only with linear systems. But today we're going to have one quadratic and one linear. And we're going to use the substitution method. We've already learned the graphing method, but today we'll be doing the substitution. Substitution is the replacement of a term in an equation by something else that you know to have the same value. You might not want to copy all that down, but instead just put a couple examples of where you've used substitution for years. Something like knowing that x equals 5 and then substituting that value for x into an expression. So put that 5 right there and working it out. That's just basic idea of substitution. Y equals 13. Another example would be what you kind of worked towards when you first started doing algebraic substitution on linear systems, something like this. If y equals 3x, then you can put 3x in the place of that y and write out an equation where you can then find the value of x. We won't finish that one, but that's the idea. Our first example is actually the type of linear substitution that you have already learned. So let's apply what we were just looking at. If y equals 6x plus 17, let's put that in the spot for y in the other equation. And that would allow us to write 6x plus 17 equals 2x plus 9. And then you would simply solve for x. I'm not going to show all the steps. You can pause and do the work, but I believe it'll come out to this. X equals -2. And then as you learned in 8th and 9th grade, then you take that x value, you come back up here. You can actually go to either equation, pick one, and plug in that value of x. I'm going to go to the top one and plug in that value for x, 6 times -2 plus 17, and you will find the y value. Y is 5. So now that you have both an x and a y value, you have found the solution to the systems. And if you remember, a solution of two linear systems, two straight lines, would be where those two straight lines cross. This next example is a quadratic equation and a linear equation. So just like when we were doing it graphically, we're looking for where the U-shaped parabola and a straight line crosses. It may touch once, it may touch twice, may not touch at all. So we're going to do it algebraically this time, though, to find the answer. Because usually algebraically will be usually quicker and a little more exact than having to use graph paper or a graphing calculator. So if 1y equals x squared minus 11x plus 28, and then y also in this other equation equals -3x plus 12, then we can simply set them equal to each other because they are both values of y. So x squared minus 11x plus 28 equals -3x plus 12. We want to do what we've always done in solving quadratic equations, and that's make one side equal 0. I'd like to keep my x squared positive, so I'll move 3x over here as a plus 3x, and I'll move the 12 over as a minus 12. That gives us x squared minus 8x plus 16 equals 0. Now, do look at it and decide, does that look factorable? Or yet you could always use the quadratic formula. I'm going to go with this one looks factorable because it's a relatively easy one. It would factor down to x minus 4 equals 0. You can use the x game to find those values. And then, of course, you will have to name your solutions from that by setting those equal to 0. Since it's the same one, I'm only going to write it twice. And for both of these, we would get the value that x equals 4. Once you have a value for x, it is substitution, so you go right back up here to either one you'd like, but obviously this one looks a little easier. And you plug in that value for x, and you'll be able to find your y, and you'll be done. So this one happens to have just one solution. So the parabola and the straight line must only cross once. And that value is at y equals 0. So as a point, it crossed at the x value of 4, y equals 0. That parabola and straight line crossed only one time at the point 4, 0. Example 3 will be worked just like example 2. I do believe there's a typo in this one though, so let's add an x in so that we have a linear term there. 2x squared plus 13x plus 15. Okay, so here we go. Usually this is the easiest one. Plug that in for that y value and write them equal to each other basically. So x minus 1 equals 2x squared plus 13x plus 15. Let's move everything to one side, make it equal 0. That would be moving the x over here with this term and moving the plus 1 over here with this term. So 0 equals 2x squared plus 12x plus 16. Again, solve it any way you would like. Quadratic formula always works. This one could be factored if you recognize first that there is a greatest common factor of 2. So let's work on that and see how much easier that'll make it. Yes, that makes it lots easier because now you could play the x game with the 8 and the 6 if you like and find these two factors. All of that equals 0, and officially define your solutions. You set each individual factor equal to 0. I'm going to continue on the next side over here. So I set 2 equal to 0, which actually makes no sense, so that's not a solution. I set x plus 4 equal to 0, which gives me x is negative 4. And I set x plus 2 equal to 0, which gives me a negative 2. So I now have two solutions for x, and now since we are substituting, we have to go back to one of our original equations, pick the easiest looking one, and plug it in for x, substitute it in for x, but you have to do it with two different numbers. So let's plug it in with a negative 4. So y equals x minus 1, negative 4 minus 1. Here's one value, y equals negative 5. And I can also plug in the x is negative 2 into the same equation. Y equals negative 3. And remember, these are points. So let's go back and write those as points. This set of information is 1 point. I'm running out of room, so let's put it up here. Negative 4, negative 5 is 1 point where the two graphs cross. And here is the other one when x is negative 2 and negative 3. So again, the whole idea here is this is a quadratic, a parabola crossing with a straight line. I'm just making up a picture. I'm not sure that it looks like that. And this would be the 2 points that it crosses at. Negative 4, negative 5, negative 2, negative 3. That's it. Every example should be pretty much like this. It will involve factoring or the quadratic formula so that you can find your solutions for x and then substitute those values in to find your y values that go with them. So, of course, if you have questions, go back and watch this video. Hey, guess what? You can come in to us for help or watch any of the additional videos.